Good morning. It's been a while. All right. I guess there's nothing to it but to do it, right? All right. So, last day we started off and we started just kind of inching our way into the formula sheet. Today we're going to take a big old chunk out of it. So what you'll find is that as we move through the course, we're basically just going to move through the formula sheet, right? And so today, I'll do it in a fun color. How about that? These formulas, believe it or not, are all from section 3.2. So today, for sure, I want to work through each of these formulas and just kind of familiarize ourselves with every single formula here. When do we use it? What you're going to see is that there's a lot of linkages going on here, right? And so that's going to be really important. And then this section here, the CVP analysis, is all from 3.3. Okay, so definitely a lot of stuff coming at us, right? But just kind of block it off in your mind. So 3.2 is definitely a big section. Okay, we're going to be talking about markups and markdowns, which when we say markup, right, I know in my mind, right, from a business perspective, okay, if I'm selling something, then I have some sort of markup on a product because I need to make a profit, right? And so we understand that concept, and so now all we're doing is we're shifting that terminology into mathematical equations like we have here on our formula sheet. And then in section 3.3, which I can never remember what CVP stands for. I think it's maybe cost value price or cost volume price, maybe. It doesn't matter. Obviously, it's not important, but it's called CVP analysis. Maybe it is for you later on, but what it means to me is we're going to be building profit functions. We've already used profit functions, but now we're going to be building profit functions. Okay, so we'll see how far we get today. I do want to spend quite a bit of time here in 3.2, right? There's a lot of formulas, a lot of ground to cover. But I think once we've defined each of these variables, so just like we did last day, right? Just as a little reminder, N is the net cost, L is the list price, and D is the trade discount. And we can have multiple trade discounts, and it would look like this, right? So I'm just going to copy this in here to our notes. So here we go. Just as a bit of a review, what did we talk about? We talked about, I want to say, linear programming. We did a little bit of linear programming. That's where we ended up just graphing all the lines and looking at all those intersections. And then we've maximized our profit at one of those intersections, right? Linear programming, maximize profit given some restrictions or some constraints, we usually call them. So we talked about linear programming. We're not going to go back there, but I do encourage you to kind of check it out again. And we talked about, we introduced some formula sheet stuff, right? We talked about the net price, which we denote by N. We talked about the list price, which we use L, right? just remember that this is the suggested retail price. Okay. And then we talked about trade discounts. D1, D2, all the way up to DK. Okay. So we established that N, the net price, and maybe I should put a little, this is the price to the retailer, right? Technically not the retailer, but for us, most of the time it's going to be the retailer. So that's why I'm gonna just commit to the price to the retailer, but it's really the price at whatever point in the supply chain that you're at, right? So it's not necessarily the retailer, but for our purposes, it's gonna be the retailer. Okay, and we talked about the formulas N equals L times 1 minus D, and we manipulated that just to kind of be able to solve for, well, obviously N, but also be able to solve for L if necessary, or D if we have to. Okay. We also looked at N is L times 1 minus D1 times 1 minus D2, right? Just opening up for multiple trade discounts. Okay. Well, and that's where I wanted to pick up. Confession time. I said I was gonna type up some examples for us to work through so we don't have to write them out. I completely forgot to do that. I was working on a little project here at home, so I got carried away, but oh well. That's okay, we'll do it old school, we'll just write out the questions. What I wanna do is I just wanna highlight these formulas that we've already talked about and covered. Okay. And just emphasize that this is one discount, and this is for K discounts, right? Noticing that we've got this little subscript K, right? DK is the Kth discount. Okay, so usually we use these little subscripts to show that, okay, here I've got discount 1, discount 2, discount K, blah, blah, blah. So it's making room for K discounts. All right. So we did quite a few examples last day. So what I want to do is I want to just expand our minds a little bit, right? And what's really going to be important is if I have multiple discounts applied, right? So if I have a discount of, in our problem here, let's do, so we're going to have discounts of 25% and 45%. Now, if I ask you what single discount would be equivalent to that, you're not just going to add them up, right? So first off, in your mind, put a little stopper on and say, oh, it's actually not the same as just adding up those discounts, okay? So when you're in a store, right? So a lot of stores, this is so stupid. The only store I can think about is that does this regularly is Guess. So you go into Guess and they'll have 50% off their sale price, right? All stores do it, but for some reason that's the only store that, I don't know. I know, weird, right? The things you think about. So 50% off the sale price, right? If it's marked down by 30% and then 50% off that, that's going to be different than, that's not 80%, right? So that's just a little mental stopper that we're going to put in place now, okay? So for our example, we're going to have to write it out. Sorry, I will get on top of it and I will type up some questions, and I might even get creative and not use the textbook ones, but usually it's safe to use the textbook ones. So discounts of 25% and 45% were given on the purchase of wine. Were given on the purchase of wine, or in my case, jeans. Okay. So here, first off, I've got multiple discounts, right? I've got 25% and 45%. So where you are in the supply chain would definitely affect that. But anyways, let's just say that this is to the retailer. The list price for the wine was $32.50 per bottle. So the list price for the wine was $32.50 per bottle. Multi-part question here. First question is going to be, what was the net price to the retailer? What was the net price to the retailer? And part B, and usually, so here we're starting off nice and slow, right? But often the only question that we would ask would be, what single discount would be equivalent to the 25% and 45%? So part B is kind of the one we're building up to. A is kind of a gateway. So what single discount? What single discount would be equivalent? Equivalent to the 25% and 45% discounts. Okay, so like I said, ultimately what we'll be building up towards is just the question like this, right? So what single discount would be equivalent to the 25% and the 45% discounts? What you would find is that you would need to find the net price in order to do that. Okay? And so here we're going from 2 discounts to 1 discount. So here we've got, we can rewrite this with just 2 discounts, right? And then we want to morph it into just 1D, right? So here, for part B, right, we want to go from n equals L times 1 minus D1 times 1 minus D2, that's 2 discounts, to n equals L times 1 minus D, that's 1 discount. Okay. We have the list price, right? We're given the list price. So here I'll say that this is given. Okay. What we need, right? And so here, actually, let's write it up above here. L is given, D1 is given, D2 is given. Okay. In order to move from 2 discounts to 1 discount, right, I want to solve for this. Solve for what single discount is equivalent to D1 and D2, right, together. But what I need as kind of a gateway is we need to solve for n in order to be able to do that. And so that's why I say, well, part A is just kind of a gateway. So it's holding our hand a little bit, right? What net price, and then you use the net price to find the equivalent discounts. But if you were just asked to find what single discount is equivalent to these two discounts, you would need to find n anyways. Solve for n to find d. Okay. So it's holding our hand a little bit here, but I want you to kind of convince yourself that you could go from this equation, right? If you're given all components except for one, and then here you can solve for one component, you have L, and then you're asked to solve for D, right? We can get there. It's going to be a multi-step thing, but that's okay. So if we go to A, question A says, okay, so we've got discounts of 25% and 45%. The list price is $32.50. What was the net price to the retailer? Okay. So what we have is we have N equals L times 1 minus D1 times 1 minus D2. So that's a 2. I need to find the net price. The list price is $32.50 times 1 minus the first discount was 25%. Remember, we have to use proportions, right? We have to use the decimal version. So 1 minus 0.25 times 1 minus 0.45. Right? Discount 1, discount 2. Okay, is going to be equal to n. Now, BEDMAS says that I need to simplify inside my brackets before I can multiply this out, right? And so usually what I do is I simplify each of these brackets before I move on. Okay, so what I get is I get n is equal to 32.50 times 0.75. And then 1 minus 0.45 should be 0.55, but let me just check. No harm in checking. I've just got a calculator on the side here, so I was going to say I'm cheating. That's not cheating. Now I can multiply this out, right? And so I get 0.55 times 0.75 times 32.50. And remember what we're going to do. We're going to write out the entire number first. And then because it's a price, I'm going to round it to 2 decimal places. Right? So the net price is 13.40625, which in monies is 1341. Rounding properly. Okay. So now I've got this net price. So this is the price to the retailer. So they bought this bottle of wine for $13.41 each, and then they're selling them for $32.50. You can see where this is going, right? We're going to have a profit of some amount, which, spoiler alert, is going to be capital P. And then we'll have expenses, which we'll call E. Right, and so this whole formula sheet is going to fall into place soon enough. Okay, so now the net price I know to the retailer is $13.41, okay, which was the question, right? What was the net price to the retailer? Great, we've done it. Now we can find what single discount would be equivalent to the 25% and the 45% discounts. And so now, right, we've set this part up, right? We've solved for n, and then now I'm going to use that n to solve for that single discount. We need to find D such that the list price is still $32.50 and N is still $13.41. Okay. So we've got N is L times 1 minus D. Okay. We solved for D before, but usually what I like to do is I just like to always just use the one formula and then I rearrange it every time. One, it makes me really quick at rearranging, right? And so that's a skill, right? And two, it's just easier to not have all these formulas, right? You could have a formula for L, a formula for D from this one formula, but I don't like to do that. So 1341 has to be the same as 3250, almost wrote 1341 again, times 1 minus D. Solving for D, right, I want to get 1 minus D on its own, which means I have to divide both sides by 3250. Okay, so we get 1341 divided by 3250 is 1 minus D, being really careful here. All right, 1341, oh, I should make sure this looks like a D there. 1341 divided by 3250. I have a decimal here, and you want to make sure that you keep all those decimal places. So we will round in the end, but and I know it sounds like I'm kind of going against my own word here, but the net price isn't going to be all these decimal places. The net price at the end of the day is just 2 decimal places, whereas a discount is going to have multiple decimal places, right? And so it's just going to be a matter of recognizing when is it going to be a price, then I can round, otherwise I have to keep all my decimal places. So solving for D here, right, I get 0.4126153846 is equal to 1 minus D. Now, a couple of ways I can do this, right? I can add D to both sides, right? And then I can subtract the 0.4126 blah, 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 making sure you keep all your decimal places. I can do that in one kind of quick maneuver, right? Or another thing you could do is you could subtract 1 from both sides, making this side negative, and then just drop the negatives because you're going to have negative some number is negative D, but then D must just be that number, right? And so what you get is you get 0.4126153846 minus 1 is equal to negative D. So now when I do minus 1 here on my calculator side, then I get negative 0.58738465154 is negative D. If I've got a negative equal to a negative, I can drop those, right? I can essentially multiply both sides by -1 or divide both sides by -1. It doesn't matter. Either way, it's going to go away. Remember, I like to have what I'm solving for on the left-hand side. And just remember the equal sign, you can flip around, right? So kind of revolving door it here. So I get D must be 0.58738465154. Right? So a single discount that's equivalent to 25% and 45%, or was it in that order? Yeah. Would be 58.74, right? Depending on how many decimal places you're going for. So the single discount maybe I should say a single discount. A single discount of 58.74%, right? So discounts typically, just like they're reporting in the question, typically we convert them back to percentages, right? So the discount is 0.587, but then when we're talking about these discounts, we typically report them as percentages. In terms of your Moodle quizzes, right, it should say reported as a percentage or just as a decimal, and tell you how many decimal places to go to, right? And so here, 58.74%, that's the 2 decimal places. So a single discount of 58.74% is equivalent to discounts of 25% and 45%. One thing that I really want to emphasize, and I will make you do, you can mark my words here, I will make you do a question like this on a quiz, on the test. I will make sure that you have this under control. Okay, so make sure you do some practice on these things. I'll write it in red because it's so important. Notice that 58.74% is not the same as 25% plus 45%, right? 25 plus 45 is 70%. Okay, that's going to be really important. Remembering that you can't just add these two up, you have to take into account that first it was 25% off and then it was 45% off that, which would make a single discount of 58.74. Okay, that's really important. Kind of in a green tone here. I will make you do a question like this. On quizzes and tests. Okay, I can promise you that, so it's worth practicing. Speaking of quizzes, I was thinking we should have a quiz on Thursday. Now, we'll see how far we get today. And then if we're able to finish all of 3.2, then we'll have a quiz on Thursday. Otherwise, we've got kind of review week next week and our first test on chapters 2 and 3. 1 is kind of baked in there, right? On Thursday next week. So that's why I want to squeeze a quiz in there just so you have a little bit of practice. Okay.
I have a question about the assignment. I was looking at I haven't looked at it super recently. I looked at it last week, but it said that our next assignment's due in March.
Oh, so that sounds great, right?
Yeah.
I don't know if I managed to change it yet. So what happened was I pulled in an old course and then it just kind of like changed the dates. Didn't make sense. I'll have to make sure that I go in and adjust those. But usually I'll give you a week to work on the assignments.
Okay. So you'll just keep us updated when our next assignment is?
Yeah, let me
Okay.
go there. How about I go there right now?
Okay, thank you. Sorry to
Yeah.
interrupt.
Make sure that I changed it. Let's see here. Was that assignment
2.
2? Oh yeah. Oh, okay, of course. Thursday, March 4th. Lucky you guys. Well, lucky and unlucky. You can put it off, not practice. Okay, I'm gonna change that. Probably not right now, but I will change it. I'll change it to assignment 2. I actually thought I had updated this. I'll make it due. I saw quite a few of you have tried it already. I'll make it due next Tuesday, just to be fair. Yeah, so I assume February 4th, and I assume that's what I meant, but that's okay. My mistake. I'll make it due for Tuesday next week, but make sure that you do it before then, or try to get it done before then, and then you'll be in good shape, right? Because it's sections 1.6, 2.1, and 2.2. So,
Okay, thank you.
Thank you for mentioning that, and I will put it up here. Assignment 2 is due Tuesday, February 9th. Try to do it before then, but I don't know. For me, assignments are just, they're for you to sit down and just kind of work through things calmly. And sometimes, I like to give you at least a week to work on assignments. Sometimes it makes the overlap with quizzes and tests a little bit tough, but so you might have to do it before the due date. Okay. I'll definitely make you do a question like this on the assignment as well. Okay. But of course. So what I was thinking was that we should do a quiz this Thursday, just a quick little, yeah, so the test will be timed like the quiz, but you're gonna have the entire class time to work on it. Yeah, so it's not gonna be kind of a short burst like the quiz, but the quiz is gonna set you up, or the quizzes by that point, will set you up to kind of be prepared for the test. So I'll finalize it, but just as a heads up, right? I'm thinking about a quiz on Thursday, just a quick little refresher on section 3.2. I'll commit to it right now. I'll put it at the top here. Quiz number 2 on Thursday this week, Thursday, February 4th, on section 3.2. How about that? Okay. What I'm thinking, just to kind of be ready for the test next week, is I'm gonna drop section 3.1 and 3.4. And if you have a read through it, you'll be very happy about that. But we'll see where we get to. All right, that's enough of that. So if we move through our formula sheet, right, some of the letters or variables, as they're called, that we'll see S, we're going to see C, we're going to see M, E, P. So what I want to do is, and we can go back there, right? We're seeing S, C, M again, E, P, S, C, E, P. Hey, this is all just a bunch of the same stuff, right? So we're gonna work our way through this formula sheet and just kind of sticking to this side for now, okay? And I just want to talk about what each of these variables are, okay? We need to define.
Professor?
Yes?
I'm sorry to interrupt. Can you just go through the question that you already did? Just the last part, like, does it like need to be like equal, like the and then that you wrote in the red one? Like, notice that 58.74%.
Oh, yeah.
So does it need to be equal?
No, because 58.74% is not the same as 70%. Right?
Okay.
So what we found was, okay, the one discount that's equivalent to 25% and 45% is actually 58.74%, which is not the same as adding the two up.
Okay.
Does that make sense? So that's where I want you to kind of say, okay, if I have to find the one discount that's equivalent, I can't just add those two up. I need to go through and do the work and find L and N at those multiple discounts. And then I can solve for D, that one discount, which we found to be 58.74%.
Okay.
Nice. We need to define. Sometimes I skip words, that's okay. We need to define some variables. S is going to be the selling price, right? Now the selling price is often the list price. Okay? Often the list price, L. So if you need to make the connection between one of the previous formulas and some of these new formulas, then that link, that selling price, is often the list price. That's not always the case, right? If you go to Winners, they've got the suggested retail price and then the price that they're selling it for, right? So in that case, those aren't the same. So we know that that is not always the case, right? But sometimes we make that leap, right? That, okay, well, the selling price, let's assume it's the list price, and then we can go on. And sometimes we have to jump a little bit. So that's your S, right? So S is here and it's here, okay? C is the cost. It's the cost to acquire this thing, right? Which might be the net price, right? C is the cost, which is often the net price. N. Okay, so I say often because it's not necessarily the net price, but at the retailer level, they are the same, right? So we need to be a little bit careful with making these connections that C and N are interchangeable and S and L are, hey, S and L are interchangeable, right? But often they are, okay? But this is the cost to the retailer? How much does it cost me to acquire, like in the past example, that bottle of wine? It cost me $13.41. And then what we said was, okay, well, if you're selling it for $32.50, then there is some markup on that, right? So the selling price was $32.50. It costs them $13.41 to get this bottle of wine. So then the remainder is going to be the markup, which is M. M is the markup. Okay. So, which in turn is just going to be, it's going to be broken down into two components, right? There's not only just the cost of acquiring the thing that you're selling, right? There's also, you have expenses, right? So you have expenses like your utility bills, your cell phone bills, you've got employees, maybe you have to rent your space, right? So all of those have to be incorporated into your markup, right? So your markup is made up of E, which is your expenses. Okay. And then of course your P, which is your profit. So ideally your markup should cover expenses, of course, but also give you some sort of a profit or profit margin, right? So what you'll see is that we've just really broken this thing down and said, okay, the selling price is the cost plus the markup. Okay, I think we're all there kind of intuitively. And then the markup, well, when I say it, right, has to cover your expenses and profit. Okay, yeah, sure, makes sense. So then what have we done here? We've just said, okay, well, here I'm just replacing M with E plus P, right? And then I've got this expanded version of, so okay, so the selling price has to be the cost of acquiring this thing, my expenses for each item, and then my profit, right? Which you could simplify as M. Now, the tricky part is, okay, so these are all related. They're essentially the same thing, right? So, right, if you plug this into here, you get C plus E plus P, which is exactly what you have here, right? So I would say if you wanted to ignore these two formulas, that's fine, right? The only one you really need is this one, and then you have to remember that the expenses and the profit, that's your markup. But they're all here for you, right? They're all here for you. Here's the tricky part with these problems. Depending on the information that you have, right, you might be better off using this formula instead of this formula, right? So these are both solving for S, right? Or maybe you have to solve for C, right? So let's pretend that you have to solve for the cost. What's the cost of an item, right? And what if all I've told you is the selling price and the markup, right? Then if you're trying to use this formula, it makes it hard because you don't have the individual expenses and the profit. So then you would use this formula. If you have the expenses and the profit, you can just jump right into this formula. So the information that we're given determines which formula, so which of these formulas to use. The information we are given determines which of these formulas we should use. Okay. Okay. How about, and just jump right into it. Let's do an example. Now, another thing that you'll see is we're not just going to say, oh, you have $48 in expenses and you want a profit of $30, right? That's too easy. Okay, so what we do is we kind of formulate them as components of each other. So what that looks like here is a restaurant. A restaurant marks up every menu item. Marks up every menu item 20% of cost. Okay, so that's of the C. So 20% of C. Okay, that can be a little bit tricky. Okay, so of cost, in order to cover overhead, overhead is expenses, right? It's another word for expenses. Sometimes it makes a nice looking arrow here. Not this time. Okay, so just use those words interchangeably, right? Your overhead, those are your expenses, so that's E. Okay. And 40% of the selling price for profit. Okay. So 40% of the selling price, which is S, for profit, which is going to be P, right? So when you read these things, just replace terms that you know with the variable that it corresponds to. The steak and lobster dinner. The steak and lobster dinner costs the restaurant $17.25. What is the selling price of the dish? What is the selling price of the dish? Okay. So what I'm going to do is, and what I typically do is I list all the information that I'm given. Now, that's easier than it sounds, right? But one thing that I will say is so a restaurant marking something up is not necessarily the markup, okay? In this case, right, it's talking about the expenses and the profit, but sometimes we use that phrase a little bit loosely, so just as a heads up. But so we've got 20% of the cost to cover the expenses, right, the overhead. So what I'm going to do is I'm going to underline this here to cover expenses. So I have 0.20 times C, 20% of the cost to cover the expenses, E, right? This is 20% of the cost to cover the expenses. So that's how you're going to transform this thing into information that you actually have. Okay, so 20% of the cost, 0.2 times C. And that's how you're going to read any, 30% of some value, 0.3 times that value, right? So 0.2 times C is E. And 40% of the selling price for profit. Same idea here. Now the selling price is what I'm multiplying by 40%. So I've got 0.40 S is equal to P. Okay. Notice that together it makes the markup. So in this case, it makes sense, right? They're marking up for the expenses and the profit. Then we're told that the steak and lobster dinner costs the restaurant. Remember, the cost to the retailer is C, right? So what we're told here is that C is $17.25. Costs the restaurant. So C is equal to $17.25. What is the selling price of the dish? Okay, so we want to find S. Okay. So of course, reading a question like this and breaking it down to these components is difficult. I'm not going to say that that's easy or anything, but once you've had enough practice, right, then it'll go a little bit quicker, a little bit smoother. Okay. So what I'm going to do is I just kind of scan everything that I have here. So I've got a C, I've got E, I've got S, I've got P, I've got C, and ultimately I want to find S. So of course my formula that I choose should probably have an S or be building towards an S. That's what we're going to get to. Okay, but so all this information, right, I can put together, and I'm going to use this formula here, right, because I've got the S, I've got C, I know E sort of, and I know P sort of, right? And so you could put it together and find M and then plug that M into here, but notice that that puts you in the same spot, right? So we're just going to go straight to here and say, okay, well, S is C plus E plus P. Okay. So what I'm going to do is I know C, but for now, only because it's appearing twice, I'm going to keep it as C just for a little bit longer, okay? And then I'm going to replace E and P because those are the weird ones that I have here. So I'm going to replace E here with 0.2 C, and I'm going to replace P here with 0.4 S. Okay? Ultimately, trying to find S. So I get S is C, which is just left on its own, E, which is 0.2 times C, plus P, which is 0.40 times S. Okay. Trying to solve for S, right? In my mind, I'm kind of feeling a little bit smug because I already know what C is. So when the time is right, I'm just going to plug C in, okay? Now you can do fancy stuff, like you can pull out a common factor of C here and have C times 1 plus 0.2. I like to play it safe, okay? So what I'm going to do is I'm just going to leave it as it is for now. And I'm just going to move this 0.4S over to the left-hand side. So I need to subtract 0.4S from both sides. So I get S minus 0.4S is equal to C plus 0.20C. Now, I'm trying to solve for S. I've got a common multiple of S that I can factor out. So here's where people get tripped up, right, is you need to pull out that common S. And when you do that, you have S times 1 minus 0.40 is C plus 0.20. C. Notice that this 0.40 or 0.4, it doesn't matter. Sometimes I like to just emphasize that it's, 0.40, 40%, but it doesn't matter. Here, all of a sudden I've dropped it, so it's okay. Right, so it's important that you have 1 minus 0.4, or even if you say S minus 0.4S, you should land on 0.6S, right? So regardless of how you go about doing it, you should end up at 0.6 times S is equal to C plus 0.20C. You can absolutely do the same thing on this side, pull out that common C, and then just substitute C in once, right? C times 1.2. For the sake of kind of keeping you with me, I'm not going to do that. I'm just going to plug in C twice, but that's something that we can do. Right? We were feeling all smug and confident. 17.25, I already know C, and you could have plugged that in at any point here, right? You could have plugged it in here and just had a number to deal with if that's what you prefer. That's just going to be practice, right? Figuring out what you like to work with. I like to just keep it as C, and then just my grand finale, I plug it in and solve for it. So I have 0.6S is 1725 plus 0.2 times 1725. 0.2 times 1725 is 345. There. Wrote from right to left that time. So 345 plus 1725 is 2070.6S. Solving for S, right, which is what I want to do, I need to divide both sides by 0.6. So S is 2070 divided by 0.6. And I'm just doing it on the side here because I was finding that it kind of glitches out when I switch to my calculator. So until we need the special financial calculator, I'll just do it on the side here, but 34.50. And that's in money, so I can add a dollar sign if I want to. Nice. So the selling price of the steak and lobster dinner, once we've accounted for all of this, right? So 20% of the cost to cover our expenses, 40% of the selling price for profit, and it costs $17.25. So then the selling price is $34.50. Okay. So an extension of that would be, what is the profit on this thing? Well, we already established that the profit is 40% of the selling price, right? So here we said, okay, 40% of the selling price is the profit. Now, just kind of as a side note, right, what is our profit? Usually that's something that we're interested in, right? So, and we just found S, so S times 0.4 is $13.80. So then our profit is $13.80. It's pretty good. Okay. Nice. Good. Good. Okay. So a little bit tricky, right? We feel like we have a really good handle on the formulas here. Okay, so it's going to be really important that you just kind of, I don't want to say memorize. You shouldn't have to memorize what any of these things mean. They should be pretty obvious, right? But M is the markup, E is the expenses, P is the profit, so on and so forth. Okay. But they should kind of fall into place. Okay. What I want to do is let's have a little break until 11:10. So kind of an 8-minute break, I guess. And then we'll keep plugging away. Through the formulas. Okay. All right, so we are back in action. Okay. Like it never happened. So we can do a mashup, right? So of all the things or the formulas that we've learned so far, and we do have to be really flexible, right? So sometimes we might need to use 2 or 3 formulas to get to where we're going. But you want to always try to kind of visualize how the formulas are going to feed into each other. So here's an example of what I mean. And I love this one because it's, and I always use it because it's about Cutie Pie Cosmetic Supply, which is really fun to say. So Cutie Pie Cosmetic Supply. Cutie Pie Cosmetic Supply, and I think it's a really cute name, obviously. So Cutie Pie Cosmetic Supply obtains boxes of hair dye, for $230 per box. Yikes. Less 30% and 10%. Okay, so 20 or 230 per box, and then less some trade discounts, right? This sounds familiar from earlier. Okay, so that's what I mean. We're kind of doing these links here. Less 30% and 10%. Presumably trade discounts. The price is set to cover Cutie Pie's overhead. Of 20% of the selling price. Okay. So remember, again, we're using the word overhead, but when you read overhead, you can think overhead expenses, right? Another reason we couldn't really use O for overhead is we try to avoid using O as much as we can because it looks like 0, so it can get confusing, right? So we use E for overhead expenses or just expenses. That was a side note. Overhead of 20% of the selling price. And to provide an operating profit of 18% of the selling price. Okay. 18% of the selling price is making up the profit. Same structure as before, right? The question that we just did together. And this is an E, Cutie Pie. what should the retail price per box be? What should the retail price per box be? Okay. The retail price is the selling price, right? That's the amount that you're selling this thing at, okay? All right. So what we have, right, is we've got this multi-step problem, right? Because I recognize this first sentence as something that I can relate to n times L times 1 minus D1 times 1 minus D2, right? I've got these trade discounts. So far I only have one option for dealing with that, right? And then the price is set to cover Cutie Pie's expenses of 20% of the selling price and a profit of 18% of the selling price. So what I'm going to do is I'm going to list all the information that I'm given, okay, and see where that gets me, okay. So it's not obvious, okay, but the 230 is going to be our list price. Now the reason for that is because they obtain the box, right, for 230 less these discounts, right? And so the larger amount is going to be the list price. And so if it's after these discounts that they obtain it at, now this is not obvious, right? So here, I'll write that in green, right? What I have is the net cost is the list price. Actually, let's do it like this. The list price is 230 and discount 1 is 0.3 and discount 2 is 0.1. Okay. From here, of course, it's pretty obvious that we can solve for n, which is the net cost to Cutie Pie, which is the cost to acquire this thing, right? And so we can use that to solve for the cost. So then, okay, kind of armed with, I'm able to solve for the cost, that's great. Then we go to the price is set to cover Cutie Pie's overhead of 20% of the selling price, right? So the next thing we're told is that the expenses is 0.2 S, right? 20% of the selling price. And to provide an operating profit of 18% of the selling price. So then the profit must be 0.18 S. And what should the retail price per box be? The retail price is S. Find S. Okay. Now, I have E and I have P, right? So I think when I'm solving for S, because I have E and P broken up already, what I'm going to do is I'm going to use that S equals C plus E plus P formula, right? Notice that I don't have C anywhere, right? But from here, right, we kind of went into this thinking, I can solve for C, right? That's the net price, right? So from here, right, we can solve for N, which is the C at the retail level, right? So to Cutie Pie, the net cost and the cost of acquiring this thing is going to be the same. So it doesn't matter which order you do it in, okay? I think it's easier to solve for C first and then use it to solve for S, okay? But a lot of the time, and this is kind of like a heads up, a lot of the time our questions will be of this format, right? Where we have to use one formula to solve for one thing, and then we use that to solve for another thing, okay? So it's not just going to be kind of, oh, solve for this, solve for that, solve for this. No, 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 no. Okay, so using n equals L times 1 minus D1 times 1 minus D2, we find that the list price we decided was $2.30 times 1 minus 0.3 times 1 minus 0.1. So our n, we can solve, okay, so 1 minus 0.3 is 0.7, so 230 times 0.7 times 0.9, right? Really careful to simplify inside those brackets before you move on. So 230 times 0.7 times 0.9 puts me at 144.90. Right. The net price is the same as the cost to Cutie Pie. So that's an important link that we need to establish. Therefore, what we've found is that the C is 144.90. Okay. I don't know why I said using. Don't really need it. I was gonna just write out the formula and then apply the formula, but then I just went for it. Just go for it, dive right in. So, okay, so now I have the C, right? So now I feel more comfortable. So now we use this to solve for S, which is what we wanted, right? And we said, okay, S is C plus E plus P. Again, using this formula because I have E and P broken up, so I'm not going to spend the time combining them to make M and then have S equals C plus M. That's the same thing, just making more work for myself. So I'm just going to use this formula. S is what I'm trying to find. C I just found to be 144.90. And then I've got E is 0.2S and P is 0.18S. Oh, okay, nice. S is what I'm trying to find. C is 144.90 plus E, oh rats, now I lost it here. 0.2S, yeah. 0.2S plus MP is 0.18S. Notice that I've got all these S's, only one variable left, and it's the variable that I want to solve for. So that's really good news, right? So what I'm going to do is, before I move it over, I'm going to combine these two collect-like terms. Sound familiar? Right? 0.2 plus 0.18 is 0.38. So what I get is I get S is 144.90 plus 0.38S. Now I'm going to move it over. The only reason I did that is because I don't want to have to deal with it later, right? I like to collect like terms before I move it over, but you don't have to. You could do minus 0.2s minus 0.18s. You'll see it works out to be the same. So you have s minus 0.38s is equal to 144.90. Now, I'm trying to solve for s, and I've got a common factor of s, so I'm going to extract that, right? Or if you prefer, just 1 minus 0.38. 1 minus 0.38 is 0.62, okay? So however you do it, I'm going to show what's going on. S times 1 minus 0.38 is equal to 144.90, putting me at 0.62 S is 144.90. So close, right? Solving for S, I can shift things around. S is 144.90 divided by 0.62. Doing it on the side here, 144.90 divided by 0.62, I get 233. So S is 233.7096774. Again, writing out all my decimals and then rounding to 2 decimal places for money. 233.71. Notice that this is not the same as the list price, right? So the suggested retail, it's close. The suggested retail price was $230. They're selling it for $233.71, right? So marking it up a little bit more. Okay, good. So pretty big problems to solve, right? But pretty manageable, I think. Okay, so just kind of keep your wits about you and say, okay, thinking at the retail level, the net price is the same as the cost, and the list price, well, that's the suggested retail price, which is not necessarily the same as the selling price, as we just saw, but often it is, right? So we have to kind of be flexible. Okay, so what I want to do is I want to go back to our formula sheet here, okay, and just kind of for a sense of accomplishment, let's just go through and say, okay, we've tackled this one, we've worked with that one, we've tackled this one, we've tackled this one, we've tackled this one. Okay, the next few that I want to deal with is this section here. Now, if we kind of look at it, I know it looks like a lot, but raw mu is just one thing. So the rate of the markup, okay. M, we already know as the markup over C, which is the cost to acquire this thing. So if you have M and C, you can already calculate the raw mu, the rate of the markup, which is just the markup as a percentage of the cost, right? So, or I guess the cost as a percentage of it. Anyways, it's the rate of the markup. Whereas the GPM is the gross profit margin. Again, we've got M, which we know, and S, which is the selling price, right? So your gross profit margin is M over S. Okay. Notice that you've got another formula for the raw mu, right? But it's just in terms of the gross profit margin, right? So if all you have is the gross profit margin and you need to solve for the raw mu, you can do that, right? Or if all you have is the markup and the cost, right, or you're able to get the markup and the cost, then you can do that, right? So it depends, again, it depends on the information that you have, right? Same thing with the gross profit margin here. You can rewrite it in terms of the raw mu, right? So the raw mu over 1 plus the raw mu is the gross profit margin. So if all you have is the raw mu, then you can find the gross profit margin without knowing the M and the S. Okay, so let's just nab these here. Okay. The raw mu is the rate of the markup. Okay, and the raw mu is usually given as a percentage, right? So it's going to give you a decimal, but we use a percentage. Use, sorry, I shouldn't do that. That could be confusing. Is a percent, only because I'm running out of room there. And then the gross profit margin, GPM, is the gross profit margin. Which is also a percentage. Okay. So again, depending on the information that you have, right? If you have M and C, and I don't mean explicitly, I mean, if you're able to solve for M and C, then you can find the raw mu if that's your goal, right? By just dividing the two. Or if it's easier, right? One thing you could do is if you have M and S already explicitly, you could find the gross profit margin and then you could find the raw mu. Or, right, if I have M and S, then S is the cost plus M, right? So you need to be kind of flexible and really kind of, I don't know, just scanning your formula sheet for things that you can do, right? And just remembering it's not always going to be a one-step problem. Often it's going to be 2 or 3-step problems, right? So here, for example, if you have M and S, right, then remember that S is C plus M. So then implicitly you have C, right? So then you could solve for the raw mu that way. Okay, so let's just do a little example. A merchant has a selling price of $13,500 for a small boat. Okay. The cost to the merchant is $9,950. Okay. Calculate the raw mu and the GPM. The raw mu and GPM, right? The rate of the markup and the gross profit margin. Okay, so I only know 2 things, so I'm gonna jot those down, right? I've got the price, so the selling price rather is $13.50, so, or 13,500. S is 13,500. And the cost to the merchant, C, is $9,950. I'm ditching the dollar signs because it's all going to be dollar signs anyways. Nothing but dollar signs. Okay, so now I have to calculate the rate of the markup and the gross profit margin. Now, there's lots of ways that we could go about doing this, and that's the fun part of these problems is you just kind of you can make things longer, harder, right? Or once you've done a few, you've got some kind of, oh, and then I like to do this, and then I like to do this. And okay, so I have S and I have C. So in terms of the ROMU, or the gross profit margin, my initial choice is probably going to be to solve for one of these two, right? In either case, I'm going to need to know M, okay? And so what I have, right, is on our formula sheet, and the one that we've already established, right, we know that S is C plus M. Okay, so here, recall S is C plus M. So I can solve for M easily, right? And so this is what I mean by implicitly we're also given M, right? And so 13,500 is 9,900, oops, comma's in the wrong place, 9,950 plus M. So M, solving for M, is 13,500 minus 9,950. So my markup is 3,550. Now I know M, and I can easily, right, now that I know M, I have C, I can easily solve for the rate of the markup. I have M and I have S, so I can also easily solve for the gross profit margin, right? For practice, what I'm going to do is I'm going to solve for the rate of the markup, and then I'm going to use that to solve for the gross profit margin. This is just for practice, right? And so here, you could just use these two formulas and then you're done, right? But for practice, I'm going to take this ROMU and I'm going to use it to calculate the gross profit margin. So now we could use that the ROMU is the markup over the, I want to say the cost, yep. And the gross profit margin is the markup over the selling price to solve for ROMU and GPM. Oops. Yeah. For practice, right, just to establish that when you're reading these notes later, potentially, I don't want you to get confused, but for practice, let's solve for the ROMU and use it to find the gross profit margin. So what I'm saying is, okay, well, I can calculate the rate of the markup is M over C. In our case, we said our markup was 35.50 and C is 99.50. 35.50 over 99.50. This is going to give me a decimal, right? Which I'm going to use in my calculations. When I report my rate of the markup, I'm going to report it as a percentage because it's a rate. So that's just how it's going to go. Okay. So 35.50 divided by 99.50 puts me at 0.3567839,196. Therefore, the ROMU is roughly 35.68%. The rate of the markup is 35.68%, right? Rounding to 2 decimal places. But we use this in our calculations. Use decimal in calculations. report as a percentage. Okay, same thing with the gross profit margin. So what we said from these formulas, right, is that the gross profit margin, if I have the raw mu, it's the raw mu over 1 plus the raw mu. Now I already know what the raw mu is, right? And so I can plug that in. So the gross profit margin is the raw mu over 1 plus the raw mu. You want to make sure that you keep all these decimal places, right? So store those in your calculator somewhere, okay? And maybe I better I better do it, but I'll write it out first. Oh, bad time for my voice to go. 0.356783919, 196 over 1 plus 0.356783919. Store in calculator. Okay. So let's go back. Let's do a little refresher. So 3550 over 9950. That's my 3550, oops, divided by 9950. That's that raw mu that I have been going on about. I had a couple more decimal places, but that's okay. I'm going to store that in slot number 1. Okay. Because now what I want to do is I want to do that stored value over 1 plus the stored value. So what I'm going to do is I'm first going to do 1 plus recall 1 equals, and we know what that should be, 1.356, blah, blah, blah. Okay. I'm going to store that in slot number 2. And then I'm going to do recall 1 over recall 2. So recall 1 divided by recall 2 is roughly 0.262962963. Okay. Let me just get it on the side here. Yep. So I get 0.262962963 roughly. But to report it, therefore, the gross profit margin is 26.30% to 2 decimal places. And from before, the raw mu is roughly 35.68%. Nice. Good. So looking at our formula sheet, and I know I'm a little tight on time here, right? But moving between these 4 formulas, right? It's pretty easy, right? Not bad. So I'm going to cross those off the list. The only 2 that we have to talk about today are involving the ROMDA, the rate of the markdown, okay, which introduces this D. S is the same, that's the selling price. D is the amount of the discount, whereas the ROMDA is the rate of the discount. Okay. So just going to grab these in here, and of course, we'll start by doing some examples. Next day. So let's do what we've been doing, right? Office hours later, in 15 minutes. Let's just talk about what each of these variables are, Okay, so S subscript R is the reduced selling price. So here, we can also talk about markdowns. Right, instead of markups, we can talk about markdowns. And that's the terminology that we use. Oh, it's been marked down by 20%, marked down by 18%, whatever, right? And so the rate of the markdown is the percentage of the markdown. So the Rande, as we call it, is the rate of the markdown. Kind of starting at the one player that's in, well, not the one, S is in both, but the one new player that's in both of these formulas. So it's the rate of the markdown as a decimal, right, from a percentage, right? So the number that you're using, again, has to be a decimal, but the rate is always going to be a percentage, right? Reported as a percentage. The difference here is that D, okay, so jumping around a little bit here, but D is the amount of the discount, okay? This is the rate of the markdown, and then the amount of the discount. So D is the amount of the discount. Okay, and this is in money, right? So just to emphasize that this is the amount versus the rate. Okay. S, of course, is the selling price again. The only new one is the reduced selling price, which is S subscript R. So S subscript R is the reduced selling price. Okay. Notice that this has the same setup as N equals L times 1 minus D, right? So notice that similar layout. Okay, so this is always going to be a lesser price is the original price or the list price from the previous formula that we worked with times 1 minus the discount, right? The rate of the markdown in this case, or the trade discount in the previous case. Okay. So let's see here. I think what I want to do is, I know I don't really have time, but let's see how far we can get. So a sport coat is marked down 30%. Okay. What is the regular selling price? What is the regular selling price of a coat marked down or marked at $100? So it's been marked down to $100. And so here, right, we want to know what the regular selling price is. So that's S. And the reduced selling price, S subscript R, is 100. And the rate of the markdown is 30%. So the Rande is 0.30. Remember, we use decimals in our calculations, and we want to find S. And then, as kind of an added bonus, what is the amount of the discount? that's where I want to leave you today. And that's where we'll start next day. So next day I'll just copy this chunk and we'll work through it. But I encourage you to work through it on your own to see if it's kind of jiving. All right, I am out of time. So I'll post it on Moodle, but we'll have a quiz on markups. So not markdowns because we didn't get to it, but markups, which is what we spent all day doing, essentially on Thursday. Again, it's going to be open all day on Thursday, but I'll give you time at the beginning of class to do it. Okay, I'll send out an announcement just to clarify. Yeah, so I'm only going to do markups for the quiz because it's a lot of stuff. So only markups on the quiz. Awesome. All right, see you guys on Thursday.